This is a Introduction to Algebra series, Vedic Math Way. It's a video number is A1. It's one of four. I split that video into four sections, and this is the first section. In this section, we talk about background and basics for algebra, where we discuss, hey, what's algebra, how is used, where it's used, how does an expression in algebra compare to a number in a decimal number systems, various values of for a variable, and we also classify a expression in algebra by two different ways. One is by number of terms in expression, another is highest power of a term in the expression. Let us continue. Here are some sutras I worked out for the algebra, and they apply to monomials. Monomials are part of polynomials with only one term. Okay, let's continue here. Add. If you're trying to add two monomials, if the flags are same, that means powers are same, we add the numbers, and number mean we add the coefficients of the two terms. Let's continue. In subtraction, in two monomials separated by minus sign, if the flags are same, that means same power, subtract the numbers, which is would subtract the coefficients. Same thing in multiply. If flags, add the flags and multiply numbers. Number mean multiply the coefficients. So we add the two flags, two powers, values, and multiply the two coefficients. In division, divide with we subtract the flags, subtract powers, and divide the numbers. So we subtract the flag of the divisor from that of the dividend. We divide the coefficient of the dividend by that of the divisor. Okay, let's continue here. So, okay, outline here, algebra basics. This section we are going to discuss is basics and background of algebra. Then we have one section on add, subtract, another one for multiply, another one for divide. This section covers the basics and background, and which students should be familiar with the background. At least the students should know what the algebra is for, how does it compare against the number math, and what does the flag means, and what does the number mean, and also it should know what the classifications are. If a polynomial, is it a monomial, binomial, trinomials, or another polynomials, and also degree of the polynomial. So the basic things students should be familiar with, and so let's go continue here. What's algebra here? Algebra is a variable math. In algebra, we use variable, usually x, y, or z, instead of numbers. Okay? Unlike number math, algebra needs support of the numbers. We use the numbers for coefficients and also which are constant multipliers, and also for the power of the variables. Let's continue. An example, in 3x, which is 3 times x, where 3 is a coefficient. In books, it's stated as 3x, which is illegal syntax for programming language. We would be using 3 times x. The star thing is multiply. In books, they would use x for multiply, and I also have variable x, and it would be confusing. So 3 star x is 3 multiplied by x. Let's continue. And in example 3 times x square, 3 is a coefficient and 2 is a power. 2 is a power, 3 is a coefficient. Let's continue. What does it do for us? Okay? Algebra allows us to express numeric thoughts even when we do not know the values of the involved numbers. So algebra allows us to express numeric thoughts even when we do not know value of the involved numbers. Let's continue here what I mean. If the problem states that 3 times square of a number plus 5 times number plus 7 is 29, we can use a variable x for the number. Okay, and that tells me 3 times square of number, 3 times square of x plus 5 times number, 5 times x. X we are using for the number we don't know a value of, plus 7 is 29. Okay, and the answer for that thing is x is 2 is one of the answers. Let's continue here. Instead of repeating a large expression, we might say that expression is E, and from now on, we would say use E instead of the number. So if there are large expressions someplace, then we might say, hey, its expression is E, and we would use that instead of the ex large expression. Okay, that gives me a shorthand notation. We would use we would be using algebra expression notation E, which is algebraic expression. Values of variables. Okay, the variables may assume one value, individuality we would call, and that's what the Glover called individuality. We might get multiple values, which is multiplicity, and we might get a value from a universe, which is universality. Universality and individuality are terms used by James T. Glover. Let's continue here. Individuality, a variable can have a single value. When we assign that value, say e.g., like example is x equal 10. So x, we have assigned a value x10, so x has, from now on, in this current context, x has a one value, which is 10. A solution of equation can give you one value, which is 5 times x minus 3 would give you x is 3. Okay? A linear equation would get you one value of the variable. Multiplicity, a variable can have multiple values. Let's continue here. We might assign multiple values in considering colors favorite to a group of fox. We might say let x be set of those colors, or we might say a variable y represent all the weekdays. That means it would get you represent Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, so we can assign multiple values. Okay, that will to a variable. That's multiplicity. We might solve an equation to get multiple solutions, like 15 times x squared plus x minus 6 is 0 has two solutions. One is x is equal to minus 2 divided by 3, or 3 divided by 5. Universality. A variable may be used to express a general value and have universal applicability. Example, a point x on x-axis can have infinite of real values between minus infinity and plus infinity. So a point x on x-axis, which is given by y equals 0, may have infinite number of values, which is real values though, between minus infinity and plus infinity is still a point on the x-axis. Let's continue. A solution of a magnitude of x is 1, has two solutions, plus 1 and minus 1, when x is real. However, for complex x, its solutions are all the points on unit circle around the origin and is in a complex plane. Let's continue here. Another example, x plus y squared, square of x plus y is x squared plus y squared plus 2 times x times y applies to whole universe of values for x and y. Let's try to compare that with the number math. Okay. In decimal number system, a number is given by a linear combination of powers of 10. This is power of 10. This is my linear combination coefficients of ith power of 10. Okay, let's continue. An algebraic expression E in x is given by a linear combination of power of x. Okay. So a number and expression are similar, except that in decimal number system we use 10 powers of 10 for linear combinations, and in a expression E we will use a powers of x. Okay, let's continue here. Expressions are similar to numbers. If you compare these, this is a linear combination of power of 10 and this is a linear combination of power of x. They're similar. Their linear combination of power 10 numbers are expressions are linear combinations of power of x. X in algebraic expression is similar to 10. If you compare these two number and expression, and if x were 10, then 2 would be equivalent. Okay, so in x in algebraic expression is similar to 10 in a decimal number system. Let's continue here. So that would mean rules developed for number math apply to algebraic expressions too. So we can use the same rules we developed for number math. Let's continue here. Classification. Let's try to see how can we classify a algebraic expression. Continue here. We can do by number of terms in the expression or by largest power of x in an expression. Let's continue here. By number of terms, you can look up this site here and for reference. So that tells you. Okay. So monomials are their one term. Example is 3 times x power flag 1 or power 1. 7, which is 7 times 0th power of x, or 6 times 5th power of x. These are single terms. A coefficient, which is number, variable, and a flag. Number multiplied by variable and a flag, that is a one number, one variable, one flag. That is a monomial. So this is a 7 here is a number, and 0 is a flag, and x is a variable here. So this is a one monomial. This is also a monomial. Let's continue here. Binomials is for two terms which consist of two monomials, like a times x plus b. This is a is a coefficient, x is a variable, and its flag value is 1. Here b is a coefficient, x is a variable whose flag value is 0. Let's continue here. Trinomials are for three terms like a times x cubed plus b times x5 plus c times x second power. Let's continue here. These are all special cases of polynomials. Okay? If you look at this site here, it tells that polynomials have only positive powers of x of variable, not negative powers, including positive powers, including the power 0. Okay? So flag value in a polynomial can be either 0 or 1 or 2 or higher. Let's continue. We can do for by largest power of terms. So if in this expression a x cubed had a power 3, flag value is 3 here, and next but monomials in here is b times x5. So its flag value of second term is 5, and that of the third term is 2. Let's continue. Power of terms are 3, 5, and 2. 5 is the largest term power. Largest power is 5. Largest flag value is 5. That tells me degree of polynomial is 5. Of this polynomial, which is a times x cubed plus b times x to the 5th power plus c times x squared, its degree of this polynomial is 5. Let's continue here. Example, e is 5, a constant term, if it's, and that's like 5 times x0, and its degree is 0. If expression was 3 times x or 2 times x plus 7, these are linear terms, okay, and these have a degree of 1. In 3x squared or 2x squared plus 3x or 5x squared plus 7 times x plus 2, highest power is 2 here, highest flag value is 2 here, highest flag value is 2 again, and they are 2, and they are, its degree is 2, and they are quadratic expressions. Okay, this is a constant. This is linear. When flag degree is 1, it's a linear term. When degree is 2, it's a quadratic expression. Let's do exercise here. Identify if the following are monomials, trinomials, are none of the above. Are these some other type of polynomials? Let's continue here. So is that a monomial? Is that a monomial? So what is that one? Is the monomials, or trinomials? Okay, let's continue here and some more examples here. Another example exercise here. Now we have to identify if they are constant term, linear, quadratic, cubic, or polynomials of higher degree. What is the degree in question? Let's continue here. Example -8. Example, next exercise is x minus 4. Next, x squared minus 4x plus 6, and so on. Let's do some definitions here. Like term, this is the term used by Glover. These are terms where power of the variable is same. We'll call same flag value. Like terms is from James T. Glover's books. Okay, let's continue here. That's an expression a times x squared plus b times x to the power 5 plus c times x cubed plus d times x squared. Okay, there are only two terms that have like terms. These are a times x squared and d times x squared. Its flag value is 2. Its flag value is 2. This is 5 and 3. The 2 and 2 match. These are the like terms. A times x squared and d times x squared are like. Or a times x squared is like the term d times x squared. Let's continue. Okay, sutras used. Let's see what we are going to do with sutras in question here. Continue. Sutra. There is sub sutra which is translated to on the flag. In the original Sanskrit version, it uses two nouns, flag and a number. Let's continue here. In using same sutra to compute differential, Tirthaji adds a verb reduce and interprets it as multiply flag by the number which is coefficient and reduce the power by 1. Okay, reduce the flag value by 1. Okay, and we will use similar liberties to make up a sutras here. Okay, we will use same. We will just play with this two nouns here, flag and a number, and make up sutras to use in addition, subtraction, multiplication, and divisions of monomials in algebra. Let's continue.